Welcome to The Explainer. Today, we're going to dive deep into artificial intelligence. We're going to pull back the curtain on its incredible power, but also take a hard look at the very real price that comes with it. I mean, it's everywhere now, right? In your phone, at your work. AI just feels like magic. But have you ever really stopped to think about what it takes to make that magic happen? Let's talk about the true cost behind that curtain. Okay, so to get our heads around modern AI, we have to start with the core technology that's driving this whole revolution. You can think of it as the brand new, superpowered AI engine. At the heart of all this are what people call foundation models. And these things are just enormous. We're talking about massive systems, usually built on what's called a transformer architecture that have billions, sometimes even trillions of parameters. And they're all trained on truly staggering amounts of data. Basically, a huge chunk of the internet. And here's where it gets really wild. This is a concept called emergent capabilities. See, when these models get big enough, they just start developing skills they were never directly taught. Things like complex reasoning or being able to follow really nuanced instructions. It's powerful, and honestly, it's a little bit unpredictable. And just look at this timeline, it shows you how absolutely explosive this growth has been. The AI's context length, you can think of that like its short-term memory. It's gone from handling just a couple hundred words back in 2018 to being able to process entire books all at once today. That single jump opens the door for so much more complexity and what we can ask it to do. But all of that mind-blowing power, well, it doesn't come for free, not even close. So now, let's get into the very real and often very hidden costs of building something this powerful. First up, let's talk about the environmental cost. The carbon footprint is just staggering. To train just one of these large models, it can pump out as much CO2 as 125 gasoline-powered cars do in an entire year. That is a massive, massive energy bill. And it's not just about electricity. All that computing generates a ton of heat. And to keep those data centers from, melting, they need a shocking amount of water for cooling. We're talking up to 700,000 liters of fresh water for just a single training run. So why can't you just run one of these things on your laptop at home? Well, because it takes something that looks more like a supercomputer. This isn't your souped-up gaming PC. We're talking about entire racks of specialized GPUs, massive power supplies to feed them, and industrial-grade cooling to keep it all running. It is a completely different class of hardware. And the costs go way, way beyond the physical hardware and the energy bill. There are huge societal questions we're grappling with, like how do we keep our data private? How can we trust a black box model when even the people who made it can't fully explain how it gets its answers? And maybe most importantly, how do we stop the biases from our own world from getting baked right into the algorithms? So, facing all of these enormous costs, the industry is really at a crossroads. And it seems like the answer isn't just to keep building bigger and bigger engines. The new frontier, it's all about building smarter ones. One of the key strategies here is a move toward smaller, specialized models. So instead of using this one giant do-everything model, you use a smaller one that's been fine-tuned for a very specific job. And the results are pretty amazing. They can use up to 90% less energy, they're faster, and they're way cheaper to run. And here's another really brilliant innovation. It's an architecture called mixture of experts. Think of it like this. Instead of the entire massive model working on your question, there's a clever little router at the front. It looks at your request and sends it to only a small team of specialized experts inside the bigger model. And this is the brilliant part. For any given question you ask it, a mixture of experts model might only fire up a tiny fraction of its total brain power, maybe just 10%, like you see here. The other 90% just stays dormant. That one simple change saves a truly immense amount of energy and computer power. It's a real game changer. Now, This whole smarter approach is also getting a huge boost from the open source community. You see, when the code is open for everybody to look at, it builds trust. It makes these powerful tools accessible to everybody, not just a few giant companies. And it lets a global community of developers innovate and improve these things at a speed that no single corporation could ever hope to match. Okay, but even the smartest, most efficient engines have their quirks. No matter how powerful these things get, we have to talk about their built-in limitations. We have to talk about the ghosts in the AI machine. The most famous ghost, and I'm sure you've heard of this one, is the hallucination. This is that weird thing that happens when an AI generates an answer that's completely false, totally nonsensical, but presents it with the calm, cool confidence of a world-class expert. It might spit out something just completely absurd. Just like this. And this is such a fundamental problem because it reminds us that the AI doesn't actually understand a single word it's saying. It's just predicting the next word that seems statistically likely to come next, based on all the patterns it saw in its training data. So why does this keep happening? Well, it's because the AI is an absolute master of matching patterns, but it's not a source of truth. It has no real-world grounding, no common sense. So its answers are just a reflection of the data it was trained on, flaws and all. At the end of the day, it's more of a statistical parrot than a wise sage. So where does all this leave us, right? We've got this incredibly powerful, but also fundamentally flawed technology on our hands. What does that actually mean for our future? The growing consensus is that the future isn't really about AI replacing people. It's about building a partnership, one where we use AI for what it's amazing at. Processing huge amounts of data, finding patterns we'd never see, while we, the humans, provide the critical thinking, the ethics, and the real-world common sense that it completely lacks. So what this all comes down to, really, is balance. We have to take the massive, world-changing power of these models and constantly, carefully weigh it against their very real costs. The cost to our planet, to our privacy, and maybe most importantly, to our trust in the information we're getting. Ultimately, you can think of this technology as a mirror. It just reflects the vast sum of knowledge we feed it, all the brilliant parts and all the biased, messy, and incorrect parts too. And that really leaves us with a final, pretty important question to think about. What are we going to choose to show that mirror next?